Alright, this is section 2, and this is all about energy. And so we're going to talk about what is energy and some calculations for energy. And so here we go. Alright, so energy. What is energy? The definition of energy. Energy is just the ability to cause change. So if we can change something, it has energy. So anything that causes change has energy. Again, we talked about in the last section that we measure work in joules. Well, work is a type of energy, so energy is measured in joules. So we can also say that energy is the ability to do work. Okay, so now something we want to think about is that when we talk about energy, we talk about systems. And this is kind of different than maybe what you're used to. Systems are things about, like, we draw a boundary around it. Like, are you talking about a single object? Like, are you talking about a baseball? Like, what is the energy of that specific object? Is it, alright, the energy coming off of that baseball, or is it a group of objects like the solar system? Is it, like, what are we talking about? Systems are specific groups, because if we don't talk about what system we're talking about, then it can get very complicated as far as what energy changes are going on. So we have lots of different forms of energy. We have electrical energy. Obviously, that's kind of just talking about the stuff that comes out of your plugs. You know, we plug in our iPods, we plug in our phones, you know, electrical energy. Chemical energy, this is anything that has, like, the bonds, that has bonds that we break or use. You know, you can think of, like, gasoline. That's chemical energy. We break the bonds from gasoline in order to make our cars go. So that's kind of a big one there. Radiant energy, obviously that's like the sun. So anything that's UV, that would be radiant energy. Thermal energy, this is specifically like heat. I'm going to use the word heat very generally. I don't like to do that because you'll find out later what heat actually is. But we'll use that real generic heat term. So, you know, basically hot. Okay. So those are just some different types. We have all different kinds of forms of energy, but those are some specific types of energy. Now, here's a really good, I think, energy analogy. So let's talk about money for a second. Let's say you have $100. We'd all like to have $100 right now. Now, you can have $100 in all types of forms. You can have it in cash. You could go put it in a bank account. And a bank account could be all kinds of things, right? You could have, you know, a savings account. You could have a checking account. You could have, you know, CDs. It could be all kinds of things, right? You could even, if you wanted to, you could go get these things called traveler's checks. Maybe you want to go get fancy and just say you have, like, some gold or silver coins. No matter what it is, however you have it, these are all things that you could have $100. We all know it would still be $100, whether I have it in one form or another. You can transfer that money from one form to another. So, like, let's say I go somewhere and all I have is, you know, my bank account that I have a check. Well, there's some places that don't take a check or don't take a debit card, right? We're in the modern age of debit cards. They don't take a debit card. So I have to have cash. Well, we know that even though it's in the bank account with $100, I can go to the bank and get that transferred to cash. It's all the same thing. Regardless of what it is, money is money. Whether it be in one form or another, it's all the same. The same is true for energy. Whether it be thermal, whether it be electrical, whether it be chemical, energy is energy. So energy from the sun, energy we get from food, that chemical energy, it's all the same thing. It's just different forms, going from one form to another. So that's what you have to keep in mind. It's all energy. It's all the same thing. It's transferred from one type to another, but it's all the same type of energy. So one specific type of energy we're going to talk about is kinetic energy. Energy of specifically moving. That's the key. Moving objects. So this is because things have motion. Okay, so because they have motion, they're going to have speed, and it's based on kinetic energy is based on not only the speed but also the mass of an object. So we're going to calculate it, and this is probably one of the most complicated formulas that we do all year because it has a squared in it. So to calculate this kinetic energy, you're going to take kinetic energy is equal to 1/2 mv squared. And I do not have a problem if you want to imagine that this formula is kinetic energy equals 0.5. If you don't like fractions, if that scares you to death, 0.5 mv squared. Either way, okay? There's your formula. Alright, so let's give this a little whirl here. What is the kinetic energy of a baseball moving at a speed of 40 meters per second if the baseball has a mass of 0.15 kilograms? Okay, so here's our equation. Oops, that should be a capital E. 1/2 mv squared. So there's our equation. So kinetic energy, mv, those are your letters. So what you're looking for, kinetic energy, I'm looking for joules, m, I'm looking for kilograms, v, I'm looking for meters per second. So we go up here. I have a speed of 40 meters per second. So meters per second, 40. I go up here, mass, 0.15 kilograms. So the only thing I have left that I don't know is my joules, which is my kinetic energy, and so I'm going to solve for that. Kinetic energy is equal to 1/2 my m, which is 0.15, times my v, 40, and I'm going to have to square it. Now the only thing that is squared is the 40, meaning your velocity. Be very careful about that. So I'm going to do that first. I'm going to square my 40. So I'm going to take 40 and I'm going to square it. So that's 1600. So 1/2 0.15 times now 1600. So the only thing I did was I took my this right here and I did that out. 40 squared. So now I squared that. So now I'm ready to just do the straight out math. Half, which is 0.5, and or you could do this two ways. You could take 1600 times 0.15, so 1600 times 0.15, and then divide it by 2. 120. Okay, or you could do 0.5 times 0.15 times 600. And you still, oops, screwed up somewhere. Oh, okay, there we go. My calculator and I were having a disagreement. The calculator was winning. So either way, no matter how you do it, you get 120 joules is your kinetic energy. Okay. Alright, next one. Oh, got excited. Okay, so again, kinetic energy equals 1/2 mv squared. So kinetic energy, mv. Those are the things you're always looking for. So 20 meters per second, because a car is moving at a speed of 20 meters per second, has the kinetic energy of 3,000 joules. What is the car's mass? So 20 meters per second, so that's your velocity. Kinetic energy, 3,000 joules, or 300,000 joules. Notice the only thing we have left is the mass, which is good because that's the only, that's the question. So this one I'm going to set up 300,000 equals 1/2 times my m, I don't know that, times my v squared, 20 squared. So again, start out. Order of operations says you have to square that 20 first. So 20 squared, which is 400. So 300,000 equals 1/2 m times 400. Now I would go ahead and just take half of 400 because it's all multiplied together, so you're allowed to do that. So 400 divided by 2 is 200. So 3,000 is equal to basically 200 m. Now all you have to do is divide each side by 200. So 300,000 divided by 200 is 1,500. or 1,500. And that's kilograms because we're solving for mass. And so that's how you would solve for mass. Now, the only one of these types of problems that we have not done so far is what do you do when you solve for V? And so that's the most complicated. Okay, so here we go. A sprinter with a mass of 80 kilograms and a kinetic energy of 4,000 joules. What is the sprinter's speed? Okay, so kinetic energy equals 1/2 mv squared. So we have kinetic energy, we have m, we have v. So 80 kilograms, so that's your mass. We have 4,000 joules. And I want to find velocity. So again, plug it in, just like you did the last one. 4,000 equals 1/2 m, so that's 80, times v, and don't forget the squared, squared. So now I'm solving this just like I did the last problem. So I would go ahead and I would take half of 80. So 80 divided by 2 is 40. So 4,000 equals 40 v squared. I'm solving this just like the squared wasn't there. So I would go ahead and divide each side by 40. So 4,000 divided by 40 is 100. So now this looks like a typical problem that you would say, okay, stop, label it, whatever. But the problem is I have the squared here. So to get rid of mathematically a square, what you have to do is you have to take the square root of both sides of the problem. So I square root both sides, and when I do that, the square root of 100 is 10, and the square root of this just gets rid of the square, leaving me v. So now the answer to this problem is 10 meters per second. So that's the only step that's basically different than any other problem than what we've done before, is the fact that when you get down to the very last step, you're going to have to square root both sides of the problem. Okay? And hopefully we'll practice this some so that if you struggle with this, you'll be able to get it. Alright, so that's kinetic energy. Now we're ready for potential energy. So kinetic energy is when objects are moving. Potential energy is for like motionless objects. I think of objects that are hanging up high usually. This is things that have basically like stored energy. For example, if you have like an apple hanging up high, it has stored energy. Energy due to position is called potential energy. So if you have an apple that stays up high in a tree, it has that potential energy due to its height. Okay, so when it falls, then that potential energy is changed into energy of motion. So if you have something hanging up high, so let's say if we draw a line here and this is hanging up high, so something that sits up here, once it falls, this potential energy that's up here is now converted to kinetic energy once it falls down. There are different types of potential energy. It doesn't necessarily have to be high. The big thing is with potential energy, it has the potential to do something. It's stored energy. So elastic potential energy is a type of energy, potential energy. This comes from something that is stretched or compressed. So of course, elastic potential energy, you think of things like rubber bands or springs. Okay. Chemical potential energy is energy that's stored in like chemical bonds. So things like gasoline, foods. So when you go and eat lunch, you are getting chemical potential energy. Your body's taking in that food and it's breaking down the bonds and it's allowing for you to get energy from those foods. That's chemical potential energy. Then we have the one we're going to focus on in here the most, gravitational potential energy, and I'm going to refer to it most of the time as GPE, but make sure you know what that stands for. And that's because it's objects that are falling, they're up high. Anything that basically can fall, meaning that it's up high, it's above the Earth's surface, has GPE. It can be calculated by using this equation right here. GPE equals mgh, and the m stands for mass, the G stands for gravity, and of course we're going to be here on Earth, so that's going to be 9.8 meters per second squared, and the H stands for the height that we're at. So how many meters are you going to be above the Earth? Okay, so let's practice that. Oh, I got ahead of myself. So according to the equation for GPE, you can have more potential energy if you increase the height and you increase the mass of an object. So two objects will have more, the one with more height or the more mass will have more potential energy. Okay, now we're ready to practice. Sorry, I got a little excited there. So we have GPE equals mgh. Alright, so GPE mgh. So the cool thing about this equation is that you always have one variable that you always know. You know that G is going to be 9.8 meters per second squared. So for this one, let's see, find the GPE of a coffee mug with a mass of 0.3 kilograms on a 1 meter high countertop. Okay, so they're giving us the mass is 0.3 kilograms and we're on a 1 meter high countertop, so the height is 1 meter. So we're going to find the GPE. So this is going to be a straight multiplication problem because we have 0.3 is m, we have 9.8, and we have 1. So just multiply those numbers together. 0.3 times 9.8 times 1. 2.94. And again, it's energy, so GPE is in joules. Okay. So now let's look if we have to solve for something besides the GPE. So again, GPE equals mgh. GPE equals mgh. Again, your G is going to be 9.8 meters per second squared. Find the height of a baseball with a mass of 0.15 kilograms that has a GPE of 73.5 joules. Okay, so we have a mass of 0.15 kilograms and the GPE is 73.5 joules. So we're wanting to find the height. So 73.5 joules equals 0.15 times 9.8 times h, because I don't know that. So with this problem, you're going to have to first multiply these two together. Multiply your 0.15 and your 9.8. Okay. So 73.5, and I don't know why I wrote that J up there, you don't really need that, is equal to, when you multiply those two together, you get 1.47, and you still have the h. Now you can solve for your h. 1.47, 1.47. So take your 73.5 divided by 1.47. So h is equal to 50. And if it's h, it's going to be meters, because your heights are always in meters. Okay. Alright, let's see. Probably one more here. Alright, so GPE equals mgh. GPE mgh. 9.8 meters per second squared. Alright, what is the mass of a hiker 200 meters above the ground if her GPE is 117,600 joules? Alright, so they gave us the height, 200 meters. They gave us the GPE to be 117,600 joules. So we're going to solve for the mass. Okay, so 117,600 is equal to our m, we don't know, times 9.8 times our 200. So again, just like the last one, you've got to combine these two before you can do anything else. So 9.8 times 200, 1960. So 1960 m, and then you just have to divide each side by 1960. So 117,600 divided by 1960. So m m is going to be equal to 60, and its mass, so again you would label it kilograms. Alright, so there's basically our energy problems. You're going to practice those, the kinetic energy, the gravitational potential energy. Those are going to be the big things that you need to take from this section and practice on.